Welcome to Product Development Days and to my short lecture here. I really wanted to share with you a few words about the road mapping and prioritization with focus on certain pitfalls that you will find in data-driven development projects. So why do I spell pitfalls with the exclamation mark? Because I'm a nerd. There's a game for Atari 2600 that came out, I believe, in early 80s, like 82. If you want to start a conversation with me later on, this is a good topic to start. So a few words about myself. If you wanted to contact me, these are the details. I am currently working at a company called Dynatrace, but I have a history of working for companies that were building products for what I call mass markets. So what does it mean really? That means that your customers are not just a single people. These are the customers that you kind of have to abstract when you think about your end users and the end user personas. And this is really important for this particular presentation because the techniques that we are going to discuss here are really important in case where you cannot really reach out to everyone who is going to potentially use your product. But first, a short question. So what are the main duties of a product manager? As you work in this role, you will probably be facing different types of duties that you or the teams around are going to do. But there's really just one thing that the product manager has to nail, which is making good product decisions. In fact, if you try to figure out what is the main or the primary artifact that is being produced by product managers, it's the prioritized list of things, of some stuff, which we typically call a backlog. And then this backlog, when executed on, leads to the maximum return on investment. And you can quote me on this, I just did it. So in like everyday work of a product manager, it's typically this little cycle that happens. We build and formulate some hypotheses, then we prioritize these hypotheses and then validate whether they work. And through that, there are implementations that at some stage are being delivered to the customers. So tomorrow, I'm running a workshop where we will be focusing on prioritization techniques. But today, I wanted to talk a bit about something a little different. So this talk is actually going to have two streams that I'm going to separate and mix together. And potentially, you will also find some similarities between these two streams. The first stream is, of course, Agile software development. And before I unveil what is the other one, I wanted to share with you what was the inspiration for this talk. It was the blog created by Death Trainer. And here's a URL if you wanted to read it. And the blog was titled "The Problem with Data-Driven Decisions." And it actually starts with a little joke. So a guy is walking through the street and he sees another guy on his knees trying to find something in the grass. And he's asking him, what's going on? What did you lose? And the other one responds, as I was exiting the bar, I actually lost my keys. To which the other one responds, but the bar is over there. Yes, but I have a better lighting here. And this little joke actually illustrates some of the problems or challenges with being data-driven. Because where is the data? If you think about this product for a mass market, there are plenty of data sources that you can consider, from customer interviews to in-product analysis, conferences, your sales team or customer support team delivering you the details of their engagements with the customers, and so on and so on. How to actually figure out which of these data sources is the most relevant and which of these data sources to use in your hypothesizing and prioritizing of the roadmap. So there's this small technique that kind of helps us figure out what type of source of data we are dealing with. So if you were to draw this little graph with two axes, one showing quantitative and the other one showing qualitative scale, and these dots representing different sources. Just a question, do you know what qualitative and quantitative data sources are? All right, so a quick definition. Qualitative sources the more qualitative the source is, the better quality of the data is. So basically, in case of your data sources for products, this is the rich data, where not only you have the answers to the question of what, but also why. Why some things are being important for the customers, what the customers are being motivated by, and so on. Quantitative, on the other hand, means that there's a lot of data. So you can draw statistical conclusions based on the sample that you have. So if these dots were representing different data sources, just as an example of my own experience, say the customer interviews would be somewhere here, right? What does it mean? From the qualitative point of view, you have all the means to actually asking very deep questions. What are you trying to achieve? What's the motivation of certain actions and so on? But how many of these customer interviews can you do? A few dozen maybe? Not a lot if you have thousands of users potentially. On the other end of the graph, we will see usage analytics. So the measurement of what the users are doing within the product. You can measure every click or every key press. And of course, from the statistical point of view, this gives you a lot of data, but then again, you don't know why people have done something or why they didn't do something. Business partners might be a good source of information, but in general, the point is that as a product manager, you want to try to move as far away from the center of this graph as possible so that your data is both qualitative and quantitative, right? So you can draw statistical conclusions from it. So if we were to color this, you want to go into this purple zone where the data is typically much harder to get, but it's also much more actionable and much more valuable. And you want to move away from the center where the data is pretty much crappy. All right, so I mentioned that there are two tracks within this talk. So what is the other one? I want to share with you a hypothesis, or maybe just an idea, that a typical Agile development behaves a lot like genetic algorithm. So who knows what genetic algorithms are? A few of you know. Right, so we have two streams, but let me share with you a definition that I have just copied and pasted from Wikipedia. So genetic algorithm is basically an approach to building certain solution based on evolution. And typically the way how it works is that you have a certain population of objects or things that you want to evolve, and then you measure whether they are fit within a specific generation, and those members of the population that score better in the fitness function are then promoted to pass on their genetic signature to the next generation. So pretty much with every new generation that you create, your population, at least theoretically, becomes better and better. So if we take a look at the typical Agile, very simple definition of how the Agile works. So you plan something, then you build something, and when you build, you can expose it to some users, and then you measure how they are using this, and based on this, you correct your course, and then you go back and do the next iteration and so on. So if we wanted to project the genetic algorithm mechanism onto this typical Agile, we would see that our representation or the population of things that we want to evolve are, say, the features or some values within the product that we want to add. And the fitness function that tells us whether these features are good or bad is the measurement techniques that we apply. Make sense so far? All right. So again, tomorrow I run a workshop, but I wanted to just steal one slide from this. This might be the good way of actually representing an idea or a hypothesis that you want to build. It consists of several fields, but what is important, two of them actually potentially represent this genetic representation or the population of things that you want to build. So there's a problem definition, some reason why you want to do something, and the hypothesis of how the solution could look like. And then going back, the fitness function will be the set of KPIs, key performance indicators, or some metrics or measurements that you perform to validate whether this actually moved the needle, whether it brings you money in the end, and the success criteria that you define for the project. So to make it a little less abstract, let's imagine that this is a backyard or a table, and the dots on the left-hand side are the ants, And the big dot on the right-hand side is the sugar cube. And the ants want to get to the sugar cube. So we have a representation of something, and the fitness function there is just a distance, like, geometric distance from the target. So you start evolving your ants, and those that are closer to the cube, as I said, are allowed to pass on their genetic signature to the next generation. So with these generations happening, you will see that each consecutive one is potentially a little closer, because those ants that moved away are basically eliminated. So you do those iterations, the evolution algorithm works. Now, what is the first thing that you actually do not see here? It's the fact that there are lots of losses. So you have tried many, many times. Many ants had to die in order for those few to actually get closer. And there are actually much, much more of those that have perished than those that have survived. Which leads us to the first pitfall of data-driven development that I want to share, which is a mindset problem. So the question is, do you have a right mindset for failure? And I have spoken with Jerzy earlier today. I gave him a heads up. These numbers come from Google. Something that I have learned during a conference several years ago. I believe it was in context of Google Mail at that time. But when Google started to perform their A/B tests on mass scale, they have ended up with 90% of failure rate. And Jerzy, if you're here, just you can correct me. There you are. If that's completely wrong, just say a word. So they said, it feels like a lot of failed attempts. 9 out of 10 experiments led to the conclusion that this is not the way to move the needle, that either move the needle in the wrong direction or nothing really happened. So they started to think how to improve that. Maybe we could filter out some ideas early on so that we do not perform A/B tests on things that don't make sense. And it took them, I believe, a couple of years, and they have improved from 90% of failure rate to 70% of failure rate. At which point they said, that's it, that's enough. We cannot improve it any further, because that would mean that we would potentially eliminate good ideas that actually seem to be bad when we take a look at them without measuring. So again, 70% of failure rate, 3/4 of ideas are bad. Quite a few of them, right? So the solution to this first pitfall is that you actually have to embrace the fact that most of your ideas will be bad ones. Which leads us to the second pitfall, which is, are we really moving in the right direction? Do we have a progress with our project? So again, let's take a look at our ants, but this time, let's imagine that there is an obstacle between the ants and the sugar cube. It might be just a pool of water. So what happens now? Please remember that the fitness function here in this case is just a geometric distance from the sugar cube. So we evolve the ants, and they enter this peninsula, and then suddenly nothing happens anymore, right? So each of the next, generations are, sitting in this peninsula, and nothing is really improving. Why? Because if any ant tries to move away, just walk around the pool of water, it's being eliminated by the fitness function and genetic algorithm. It's not good enough to promote its genes and its signature to the next generation. So what is really the perception problem with this? There are actually potentially two things there. First is that we actually do not have any progress, and the second is that we do not see the progress, which may seem to be the same thing if you think about it. So we will get back to this first one in a second, but first let me go to the second one, to the B, that we do not see the progress. So who knows what this black object is on the car? All right, let me actually quote a definition here. In short words, a device that, if you have a car with a combustion engine, allows you to submerge the car and drive maybe across the river or a pond, and the car will not die. It will not be flooded with water. It allows for the air intake to be a little higher than the regular one. So the question is, how do you measure if this feature, if it was a feature of a car, how do you measure if it was successful? So if you apply like a blind logic to it and say, okay, this is a car needs to drive, so if a feature is successful and really being used, we can maybe measure whether, or how many kilometers we drive with this feature being actively in use. Does it make sense? Let's take a look. Wheels, all right, 100% of time. Without wheels, the car is not driving. So wheels are really important for the car. Headlights at night, okay. Windshields, yes. What about the snorkel? How many meters do you think a typical river has in width? 100 meters? How many times would such a river be crossed during the life cycle of a car? 100 times at most? So you have 10 kilometers compared to what, 500,000? Fraction of a percent. Conclusion, this feature is useless, right? It's useless. It's almost never used. Then how do you explain the prices? So, this is a simple example, of course, but the point to take away is that if you do not see the progress, perhaps you haven't set your success criteria right ahead of time. In case of this snorkel, of course, it's not the length of the road that is used with the snorkel, it's the length of the road that is used after you cross the river, or the fact that there is no road afterwards. So you need to set the criteria ahead of time. But again, I mentioned earlier that you can actually lead the project to a deadlock. So what typically happens, and this is the reality, what typically happens in a data-driven development project when you hit a deadlock and you do not see a progress anymore? So, we have wasted enough time already, nothing is going on, the money has been invested, so now we need to move faster, but we cannot risk anything anymore because we have already wasted some time, so we have to make safe decisions. So now let's collect some more data so that we can move faster, and we can have to collect the data faster as well and do the safe decisions with this. So effectively what it means is that we are moving to the center of the graph here. This is where the unreliable data lives, because we are pushed to make safe decisions and we are pushed to move faster. So going back to our second chain of thought here within this talk, how do genetic algorithms actually deal with deadlocks? Anyone knows? Mutations, exactly. So let's take a look at our ants again. And let's add the mutation factor to this. Let's imagine that a couple of these ants learned how to jump, or maybe they have grown a pair of wings. But effectively, they have moved across this pond, and because they were closer to the sugar cube, the fitness function promoted their genes. So with a couple of more generations, you will see that the ants have actually moved to the sugar cube. So what are the mutations, really? They are seemingly random acts of change, sometimes dramatic, because again, some of these ants might have jumped into the pond and died. And they seem chaotic at first, if you look at them. So if we were to underline a bunch of these adjectives here, random, chaotic, and unsafe, and then remember what is the typical reaction for the deadlock in the Agile project, you end up with the conflict of interest. Because suddenly you're in the pressure to make safe decisions, and it seems that the way out of it is actually to do something crazy. So what is really the answer to this deadlock and the fact that you have no progress? Question, what is the role of a domain expert, or who is a domain expert? It's pretty much someone who has been around for some time, has a throughout knowledge of the domain, has seen some stuff, weird stuff as well. But the point is that this is the person that can potentially extrapolate from even the poor data that you have collected onto something, solid. So this is the person that can move us in the opposite direction right now, based on potentially not very good data into something that is actionable. So the question, is a domain expert a visionary? Well, he or she may become a visionary if good circumstances are provided for that, but typically the other way around it doesn't work. If someone says that he or she is a visionary but is not a domain expert, that person is typically a fraud. So here's a little marketing plug that I have to apply. So I'm actually privileged to work in a company where we have a visionary. Bert Greffeneider is our CTO at Dynatrace. And just to maybe illustrate really briefly, the type of thinking that he has promoted, if that was a time axis, and that would represent the type of thinking around APM products. APM stand for Application Performance Management, which basically means that what we build is an application or a solution that helps, that measures the actual applications, the business applications of our customers, and then figures out whether there was a performance degradation and where, and helps to resolve these problems. So, just really briefly, the evolution of these applications for many years was around this premise that if we collect lots of data, someone will figure out what to do with it. And what Bernd has suggested is that people are just overwhelmed with the information at some stage. So unless the product itself provides the analysis, it is actually becoming less and less useful over time. Just by the way, if you wanted to take a look how it really works, my colleagues can deliver you a demo outside of this room. So my suggestion to the pitfall number 3 and pitfall number 2A, which is about the deadlock, is to basically grow your domain experts. But that sounds easy, but it's really not. Because those guys are typically not very vocal. So you might say, well, we do not have domain experts, so what do we do now? Well, let's do a workshop. Let's hear what are people's ideas. And then, which is all fine, by the way. And then you might be tempted to say, now because we have no idea what to do, let's use democracy to vote on things that we are going to do. Which leads us to pitfall number 4, which is the unexpected pitfall of democracy. So as I said, people have equal rights to share their opinions, but because of the fact that not everyone is an expert, people do not have equal rights to make the final calls. And offline, I have a personal rant about it because my fingers were badly burned in such an environment at some time. So what really is the case is that product managers have this role of collecting different ideas, of course, but in the end, they are the accountable people and those responsible for making the decisions, of course, with other stakeholders and with help of domain experts. But these are the people who actually, drive the process of decision making. So let's rewind a bit. What if we do not have domain experts? That's pitfall number 5. We don't have domain experts. Typically, the thing is that typically you do. They might not be very visible, but they typically exist within your environment. But the trick is to be able to separate the noise from the actual true information, and in realization that people who are loud are not necessarily people who are knowledgeable. I think that everyone has an example of such a person who is loud but not necessarily making sense in our experience, right? So we as product managers, we have to listen to everyone and try to figure out which of those people are actually potentially domain experts or candidates for becoming domain experts. And they might be very well hidden, just by the way. So these might be your grumpiest developers that have been with the company for 20 years, and they are always saying that we are doing the bad thing. Or these might be your support guys who are coming back to you over and over and saying that, or asking the same questions, why are we not doing these things for the customers? These might be the guys who never wear a tie, like myself right now. Typically, the way why they are not very outspoken is that the type of approach that we apply to domain experts is that they need to prove it to you. But it's really, really hard. It's really, really hard to prove that you have been able to extrapolate from the poor data onto something that makes sense. All right, so as I said, in a typical environment, you have an ability to grow your domain experts. So the question is, how to do it. I don't necessarily know how to do it, but I know how to not do it. So maybe you can apply like the reverse logic to it. And so here are a couple of hints on how to not grow domain experts. So the first one is what I call a compulsory role change or a bus factor. Who knows what the bus factor is? Most of you know. All right. So you have been exposed to it. Well, bus factor is okay, of course, but compulsory role changes mean that no one is ever allowed to become an expert in anything because they're being moved around between projects. In order to really dive deep and to become this like a T-shaped personality, have a broad coverage, but really be able to have this leg of a T letter and dive really deep, you have to be given some time and opportunity to do that. So the second thing, you are, surrounded by engineers, and probably one of them, or maybe more of them, is your domain expert. So let's now force them to speak up. Let's put them on a stage. Let's make them forcefully share their points of view. If anyone is an introverted person, you probably know what it ends up with. It's a complete shutdown at this point in time. Especially if the mindset of your company is completely incompatible with failure, so you're expected to only share good ideas, and especially if your philosophy is that data-driven decisions are the only way to do things, and especially if you have this prove-it-to-me mentality with your managers. So I want to close this presentation with a quote from the blog post that I mentioned earlier. It has a bad language, but let me actually read it aloud. The highest rewards come from the biggest risks. Sometimes you need to be willing to say, we believe in this, fuck what the data says. That's when things get exciting. I hope it now makes sense for you to sort of combine Agile software development with genetic algorithms. And I still think I have like 3 minutes left, so let me share. Let me be a visionary for just a second. Let me share my 6-year prediction right now. I have predicted this a year ago already, so it's not a 7-year prediction anymore. And so there's a bit of reality check there. So anyway, going back to this diagram, Agile process and this overcast of genetic algorithm. So I have a background in engineering as well. If I see that something is an algorithm, my first question is, can we automate it? Can we automate doing an Agile project? So let's take a look at the tool set that we have. We can probably imagine quite easily adding a feature within the product that allows the customers to really be very vocal about what they think about the product. Imagine just a record button and someone is ranting, this is not working, I hate it, and I would really like it to be this and that way. Then we can apply natural language understanding techniques. They are really, really awesome these days. And if you think about the backlog as being a combination of strategical decisions for the company and just tactical decisions, making sure that your customers who have already been acquired, that they are retained properly, then perhaps, again, a guess, 80% of your backlog could be filled just based on this automatic analysis of what your customers say. Again, statistically valid, qualitative data, right? And then if you apply A/B logic to this, you can test it and maybe automate it as well, especially if we added this one more element there, which does not exist today, but who knows, self-organizing software. Can you cut 80% of your development cost, potentially? And that's the question I want to leave you with. If there are any questions to me, I'm really welcoming you to reach out to me after the talk. And as I mentioned earlier, you can start with retro computers. That will be even better. Thank you.